So as we work our way through chapter 8, it is all about patterns. There's two ways that we can talk about patterns. One of them is called a sequence, and one of them is called a series. We're going to start with a sequence today. Today is just about sequences, and sequence is just a pattern of numbers. So a sequence is a pattern of numbers. Now what that means is you're going to be given like a list. So you would be given a whole bunch of numbers, and then with those numbers, you would be asked to figure out what the next number in the pattern would be, or you would be asked to figure out what the pattern was that produced every single one of those things. Okay. Before I do this, I want to kind of show you what the terminology or symbology behind it looks like. There is a domain, and these are like the numbers that you plug in. Oops. These are the numbers that you would like plug in to the pattern, like you're saying the first term, the second term, the third term, and so on. So these are represented by n. So n is like there's 1, 2, 3, 4, 5, all the way up to whatever you get to your last number. Okay. So it's like numbers 1, 2, 3, 4, 5. This is like saying the number term. So this is like saying the first term, the second term, the third term, the fourth term, the fifth term, and so on. Okay. That's what this thing is saying. The range they're really like the numbers in the pattern, or the numbers that you would get out if you plugged in something into the formula. The number that you would get out of the formula, that's the number that's actually in the pattern. So if I told you the first term is 3, the first term part would refer to the n. The 3 part would be the number in the pattern. That's the range. Okay. Now these are a little bit different notation wise. So like the first term would be A1, the second term would be A2, the third term would be A3, the fourth term would be A4, all the way until you get to the last term, which would be AN, whatever that last term is, right? So that's just what you're kind of looking at. The domain is the numbers that you plug into the series or the sequence. The A1, A2, A3 is the number that you get out after you plug something into it already. Okay? Any questions on that part? So the next part is just more definition. There is something called an infinite series, and there's something called a finite series. These are sequences, sorry. So we have an infinite sequence and a finite sequence. This means infinite sequence would be numbers that go from like 2 to 4 to 6 to 8 all the way on forever and ever and ever and ever. They never ever stop. A finite sequence would be if I give you the pattern and I said you had 2, 4, 6, 8, and 10. And that was the last number in the pattern. Now in this case, the patterns are the exact same. One of them just doesn't stop and one of them does. That's the difference between finite and infinite. Okay. Infinite means that it goes on forever and ever. Finite just means that it stops and it's all done. Okay. So one of the things that you're going to be asked to do a lot of, because it's kind of the intro to sequences and series, is they might ask you something like write the first 6 terms of, and then they'll give you a function. And the function is going to be in terms of n. So in this one, they would tell you something like an is equal to 2n plus 5. So an is equal to 2n plus 5. So if I'm asking you for the first term we would plug 1 into, right? So n equals 1 would give us the first term, n equals 2 would give us the second term, n equals 3 would give us the third term, and so on. So if I wanted to figure this out, I could just use this shorthand notation, where I would say the first term, A1, is equal to 2 times 1 plus 5, which is 7. If I ask you to find the second term, A2 is 2 times 2 plus 7, or 2 plus 5. So this would give us 9. And then hopefully you'd be able to see kind of what's going on with this pattern, and you wouldn't have to calculate every single one of them out every single time, right? If you notice, I'm just taking 2 times the number of term that I'm looking for, and I'm adding 5 to it. So if I want to find my third term, I'm going to take 2 times 3 plus 5, which is 11. My fourth term is 2 times 4 plus 5, which is 13. A5 would be 15, and A6 would be 17. So this is how we would find our first 6 terms. Now, I know this is not groundbreaking stuff. You're just plugging a number in, and hopefully it makes sense when you plug that number in. So that's one notation that you can see. The AN notation is probably more common than the other notation, but I want to show you that one as well. So let's say I want to find the first 6 terms. So if I ask you to find the first 6 terms of f of n equals -3 to the n minus 1 power. Now this is also something that's a little bit different. You're going to see a lot of weird powers where they're going to be -1 powers. There's going to be n minus 1 powers. There's going to be a lot of weird powers in this chapter. Okay. What I would suggest to you is that you use all of the examples that we're going to go through as things that you can kind of use in the future. So a lot of the things that you're going to see in the examples that we do, you're going to say, well, I don't know how to find a pattern, or I don't know what I'm looking at with the numbers that I see in front of me right now. So let me go back and look at my notes and see some of the things that were used in the past. Maybe I can try those. Like maybe I can use a to the n minus 1 power, or maybe I could use a negative exponent or something like that, because that might jumpstart something to help you find a pattern. So if I want to find the first several numbers of this, I'm going to plug in 1. When I plug in 1, I get -3 to the 1 minus 1, which is the same thing as -3 to the 0. And what is anything to the 0 power? 1. I can do the same thing with f of 2. So with f of 2, I'm going to do -3 to the n minus 1. 2 minus 1 is 1. So -3 to the first power is -3. If I wanted to find f of 3, I would get -3 to the 3 minus 1, which is going to give me -3 to the second power. -3 to the second power is 9. 4 is going to be -3 to the 4 minus 1, which is -3 to the third power, which is going to give me -7. F of 5 would be +81. And then f of 6 would be -343. Now, what I want you to notice right now is that a lot of people really struggle with this exact concept right here. This is a concept that I kind of want you to make a note of so that you can see it. Notice what's happening with every single one of my term numbers. So as I look at my new terms, these right here, disregarding completely what the values of these numbers are, what do you notice about everything that's circled in red as we go from least to greatest? Positive, negative, positive, negative, positive, negative. That's one of the things that people really struggle with when they're dealing with patterns and creating their own equations. They really struggle with the fact that sometimes we can go from positive to negative, positive to negative, positive to negative. So just keep that in mind, that this is something that you can kind of think of. So I'm going to make like a mental note somewhere in my notes. That's maybe not a mental note there. I'm going to say something like n minus 1 power could alternate negatives. So an n minus 1 power could give me something where I'm allowed to then alternate negatives. Negative, positive, negative, positive, negative, positive. Right? And that may be something that's kind of helpful in the future. All right. So I'm going to give you one and see if you can figure out what's going on with it, and then we'll talk about it and kind of see what's happening. So let's say that we have the sequence -1, -8, -27, -64. Okay. And this one's going to go on forever, but we don't really care about it. I want you to try to find the pattern for that one. And I want you to try and find the pattern for this one. Okay. I want you to try to find the pattern for both of these ones on your own. See if you can figure out what's going on. Some of them are going to be very clear to you. Some of them are not going to be as clear to you. But I want you to just try to see what you can do. All right, so let's talk, see what happens. Now, the way that I do this, the way that I like to do this is I like to try and compare these numbers to see what's happening. Now, I take care of the negatives later. I usually just try to find a pattern first, and then I try to see what's happening with the numbers later. So what do you notice about each of these? Is anyone able to come up with anything? The cube, right? 1 cubed is 1, 3 cubed is, or 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. How would I possibly make that number how would I make that number negative and also have the cube root be perfect? Could I just take -1 cubed, -2 cubed, -3 cubed, -4 cubed? Would that work with the problem? So really all I'm doing is I'm taking the opposite of this number and cubing, right? This number is n, right? This number is the n term. So if I wanted to find a pattern for this, I could just say I want to take the opposite of whatever n is, and I want to cube it, and that would produce every number that I ever want. Okay? So that's something to kind of think about. Okay? So this is my first term. This is my second term. This is my third term, fourth term. So we'll go through this tomorrow, but the way that you would do this one is n times n minus 1. So if you
for the first one, could the negative sign be on the opposite?
technically, yes. Yep.